Number 1, write a recursively defined rule and an explicitly defined rule for each sequence below. So, recursive is how we describe the pattern. Explicit is how we find any term in the list. Recursive, you need to know how to set up using symbols. Explicitly is luckily on your reference sheet if you flip to the back of your book. So, this first sequence here, what's the pattern? 7.25, 13.75, 20.75, 26.75. It looks like we're adding the same number, and that common difference is 6.5. We're adding 6.5 each time. You could check that by subtracting two terms that are next to each other. So, recursive, I'll do in purple. The first term is 7.25. And to get to the next term, you add 6.5 to the term before it. The explicit rule for this sequence is a sub n equals 7.25 plus 6.25 times n minus 1. That comes right from the reference sheet, and this is actually a function here, because if you want to know the nth term, you just plug in n. The recursive rule just describes the pattern. This sequence here, 80, 100, 125, well, that's plus 20, that's plus 25, so it's not arithmetic, which means it's probably geometric. So what's 100 over 80? Well, that comes out to be 5 halves, 5 fourths, not 5 halves, 5 fourths. What's 125 out of 100? That also comes out to be 5 fourths. So our common ratio is 5 fourths, or 1.25. We're multiplying by 1.25 here. So recursively, the pattern is start at 80, and to get to the next term, you do 1.25 times where you're sitting now. Explicitly, if you want any term n, you start at 80 times 1.25 to the n minus 1. This is an exponential function here. This is a linear function. Explicitly defined rules are just functions. Recursive ones have those two parts where there's a sub n's on both sides. Number 2, a sequence is defined by the first term is 8, and the nth term is 3 fourths times the term before it. So this is a recursive rule here. This is a recursive rule. Write an explicit rule for this sequence. Well, this says start at 8, and then the pattern is multiply by 3 fourths. So this appears to be geometric, where I have a first term of 8 and a common ratio of 3 fourths. So the nth term is given by 8 times 3 fourths to the n minus 1. That's the explicit rule for that recursive sequence. They represent the same sequence, they're just different styles, different types of ways to write out the sequence. Number 3, Jenny planted a sunflower seedling that started out 5 centimeters tall, and she finds the average daily growth rate is 3.5 centimeters. Find a recursive formula for this height of the plant. So we know that we're starting out at 5 feet tall. Well, each day the average daily growth rate is 3.5, so each day I'm adding 3.5, which brings me up to 8.5. Then I add another 3.5, which brings me up to 12. Then I add another 3.5, which is 15.5. So this pattern keeps continuing because it's an arithmetic sequence with a common difference of 3.5. Well, to write a recursive rule, I need two parts. Start at 5. I need to tell it where to start. And then to get to the next term, to get to the a sub n plus 1th term, I'm sitting here at a sub n, and I add on 3.5. A bouncy ball rebounds 90% of its height. Craig drops a bouncy ball from a height of 20, so we're starting off at 20. And to get to the next term in the sequence, well, I'm only keeping 90% of the height. So 0.9 times a sub n. That's a recursive rule for this sequence. Start at 20 and you are only keeping 90% of it. So that's the recursive rule for this geometric sequence here.